This is part 1 of the 8-8 handout on reducing rational functions. We're going to start by looking at number 3 here. We're going to go ahead and factor the top, and we notice that both terms in the numerator have an x in them. So you can factor out an x, leaving you with x plus 2. On the bottom, it's the difference of perfect squares, and that factors to x plus 2 times x minus 2. The x plus 2's cancel, leaving us with x over x minus 2. Okay, so the x plus 2's will cancel out, leaving us with an equivalent function, x over x minus 2. In number 5, that's also the difference of perfect squares, and the numerator factors to 3x times 3x to make the 9x squared. Since it's a difference, you're going to have a plus and a minus. And 2 factors of 4 are 2 and 2. And now you notice here that when you do the foiling, if you do 3x times the outside, negative 2, you get negative 6x. On the inside, you get positive 6x. And they cancel to create that missing b term in the middle. In the denominator, this is not the difference of perfect squares. It's a big trinomial, and it has a leading coefficient of 3x squared, as a leading coefficient of 3. So instead of just x and x, we need 3x times x to make 3x squared. On the back end, we're going to have 2 and 5 multiply to make 10. And what's nice about that is when you have the 2 and 5, the 5 on the outside, when it multiplies by 3x, that's going to make 15x. And then on the inside, you have a 2x. And 15x and 2x add up to 17x, which is what we need in the middle. So we notice that the 3x plus 2's cancel, leaving us with 3x minus 2 over x plus 5. Finally, if on this worksheet they were going to ask us for the holes in the graph, this is something that you'll see on Friday's test coming up, this week's test. If they were asking us for the holes in the graph, first of all, we would know that the x-coordinate is at negative 2. This is for number 3. Because negative 2 is the value for x that would create 0 in the factor that was able to cancel. Remember, that's called a removable discontinuity. Negative 2 is the value that would create 0. What we do then is we take the remaining function, x over x minus 2, and we plug negative 2 in for x and find out what y is. That'll give us the y-coordinate of the hole. So we have negative 2 over negative 4, which is positive 1/2, or 0.5. So that's where the hole in the graph would be. You could do something similar for number 5. That's it for now.